Hi everyone, Assalamu alaikum. Today we are at GIS Lassipora grid station, but I must tell you the main features first of this grid. It is the one and only GIS type grid in the whole valley. So basically the main difference is that it is insulated by gas, so that's why it's called a GIS grid. So right now we are here on the 220 kV side of the grid station. You can see these are the transmission lines coming in. This is the 220 kV transmission line. These three phases are coming in from one line. Similarly, you can see here, you can hear the hissing sound of these 220 kV lines due to the high voltage. It's called the corona effect of these lines. So as you can see, this is a lightning arrestor here. So in case of any surges, it provides a medium to dissipate the high currents in the line. So these are the lighting arresters attached before the line goes into these buses here. Okay, so let's get forward and see what we have. So as you can see here, let me show you something here. Yes, these insulators are here, like this and this one. These insulators provide insulation from the main support system. So after that they go into this is a bus bar. It is insulated, and after that SF6 insulation is there. So here we also have, this is made from Siemens Limited. After that, these three-phase lines buses, which these lines go inside these buses, which are insulated by SF6, and these prevent the hissing sounds and all that phenomena that happens in these lines. So after that, as I may show you forward, after that they go, these become the 6 buses from 2 transmission towers, sorry. So one is another is here auxiliary for, has not been commissioned yet, but the lines are coming from the transmission towers, so it has to be done. So as of now it has not been commissioned. So as you can see, there are 1 2 3 4 5 6 buses which go inside this. These come from that side, and after that this auxiliary, it is not connected, so it has been just put as it is. So as you can see here, I will show you the wire ACSR conductor. This is a ACSR conductor. Let me bit focus on this. You can see this inside of that is a steel wire it supports, and after above it is aluminium. So this is a typical ACSR conductor which is used in these transmission lines. So after that these buses go inside this is the yard of circuit breaker. So we will go and enter the circuit breaker section of this grid station. It is not like those AIS grids where the circuit breakers are outside the open atmosphere. So they are put in the building, GIS building. So here, let me see if it is, yes, this is open. So here we are in the control room first. Before that, let me see the circuit breaker section. Yes, this one. Here we are. Yes, that is the main part of this, main crux of this GIS grid here. As you had seen these buses, those buses are here. So you can see this bus here is a voltage transformer. That should have been a potential transformer, or I don't know about that, but this one is a voltage transformer here. It measures the incoming voltages and subsequently transfers the information to a relay, so that in excess voltage the system can be tripped. So this is that side of the bus. So let me show you this and over here you go. So first these first where do these lines go. So talking about these 6 lines which were incoming, They go into separate sections here. So here is the ones of 3-phase. This is the another section with a separate voltage transformer, and here is also PT another. So this is a SF6 circuit breaker. So this all mechanism is made to isolate the whole system. So as you can see, it is gas filled, 850 kilopascals of pressure it has inside gas. So here you can see the pressures of each of these buses. So they help us to maintain if there is any arcing, and if we need to break the circuit or something, so it minimizes the arcs and extinguishes them inside the system, so that there would be no loss of energy. As you can see, all the mechanisms are very typical. This is a typical isolator here. So before isolating mechanism, you have to use a circuit breaker. Then after that, an isolator is used for additional protection. So as of now, this isolator is off. So after it turns to red, then it goes on. As you can see at the above one is on the red. So this is a typical isolating. After that, these boxes mechanisms are all circuit breaker mechanisms. They have a spring attachments. So there is a spring mechanism here. Let me show you one of them so that you may understand a bit better. This is open here. This is the mechanism of circuit breaking. Let me show you the spring. Here you can see the spring. This spring is charged by a motor. So in case when they have to break the circuit, so they use the spring, and spring transfers some energy and breaks the circuit. These are charged like that. This mechanism seems more I would say technically advanced system. So AIS can be understood, but this is just like a black box here. You can see the above auxiliary bay above. So here let me give you an overview of this system. So here after the circuit breaker, there are two main buses which are charged, which are on the outside of this system. So one is the main bus and another is the auxiliary bus. So they are charged by 220 kV lines. So let me show you this. These are the feeders, feeder controls, trafo feeders, transformer feeders. This is the bus coupler system here. So you can manage all these systems. So this is the sigma board diagrams here. So you can see here how these are incoming and outgoing. So as I have said, two bus bars are there which are charged by these two lines. You can see this shows that this line is connected, and this shows that this is disconnected by isolator. It is all mechanized and all controlled by some system. Let me show you the inside of this. This is all computerized system here, and it can't be explained like this. These are the lines that are here. This all mechanism is based for extra protection of the whole system. Let us go towards the relay section of where the relays are added. See, this is a soundproof room here. So here you have the protection panels, 220 kV bus bar protection panel here. Here is the numerical relay master control unit, MCU it's called. These are the relays here. So they are all controlled by these panels here. They will give all the data information. So this is the energy meter here, shows the consumption of energy. These are the relays, 220 by 32 kV transformer 1 panel, transformer 2 panel, protection panel. These are all numerical relays and all that sort of things are happening here. I had been shown with a lot of relays, but I don't remember the thing. Bus bar protection relay, supervision relay. So in general, these are some of the protection relays. So I have not gone through all of the protection relays, but because that lies in our 6th, 7th semester curriculum. So now I'm from the lower semester. So as of now, these are all the protection mechanisms that happen in this. So this is a panel for all the transformers. It shows you each tracking and what is happening. You can see, so these are remotely connected on the main grid stations unit, which is here. So they are controlled by computers there. So you can see all the data and all the details of these systems on that SCADA computer there. So let's end up here. So I will go outside and show you the other side, bus where the buses are coupled. So here we are. I had shown you the buses, these 4 buses, one for auxiliary and another is the main bus. So these buses are coupled here. Then after that these single line is coming out of these buses after that. So SF6 protection is up to this point, and after that they are in the air protection. So these are our way here. So these are our single phase transformers. There are 4 units here, 1, 2, 3 and 4, and out of these 4 only 3 work, because another is a auxiliary one, so in case it is necessary to use it, so they will use it. So these are single phase transformers. So let's get towards one and see its ratings, and let me tell you about, let me show this. This is a very big transformer. I haven't mentioned any sort of transformer in any of my videos. So this transformer you are seeing is one of its own transformer. So here is the name plate. I can feel the vibrations on the ground of this transformer. It is that huge and that sort of work it's doing. So here you have ONA and ONAF, oil natural, air natural and oil natural, air forced. So the total weight of this transformer is 73,000 kgs. Total weight of the transformer. That is unbelievably huge. So these transformers are 53 MVA transformers. So they are manufactured by Indotech Transformers Limited. So it's a copper mount transformer. So these are some of the details of the conservator tanks and all that. So let me give you a brief overview of this transformer. So don't worry about this. This is a, which I had told in the previous video, this is an NIFPES system, explosion prevention and fire extinction system. So it is a nitrogen gas to prevent any damage of the transformer. So this is a drying system. So these are the conservator fins. This is a tap changer system. This is an oil natural air force system. This is a breather here for the tank above. This is the conservator tank. It has some meter there. It shows the level of the conservator tank. So it is, as of now, it is towards empty because the main oil is inside this one. So this is a single phase transformer. So only one line goes into this 220 kV line. And similarly, there are similar to these, there are 3 units. So this is cooler cabinet unit. Here you have different meters, oil temperature indicator, winding temperature indicator units. They show the oil and winding temperatures. So in case there is a high temperature, so respective relay will get pushed and will turn off this system. So here you have a Kalman Transfix transformer gas analyzer. So this is a gas analyzer from GE Energy. So this analyzes the internal gases and checks where from these gases are coming. So it helps us in fault detection, early fault detection. If there is some uneven type of gas present inside this system, so it may indicate from where that gas is coming, and it may give us an early indication of where the defect lies. So here you can see this transformer, the secondary side. So it charges this primary bus here, 33 kV bus. So it is charged by these transformers. So after that, and let me show you this. This is the secondary side. You can see how many lines are coming out from this transformer. So this is separately used. This is the red phase, this is the yellow phase, and that is the blue phase. So 33 kV lines are coming out of these three transformers, 3-phase 33 kV from all of these three transformers. So then after that, this is the bus coupler bay. So here you can isolate and couple all the buses together in case there is a need of more supply. So this bus coupler bay helps to manage all that thing. So here you can see these are remote buses which are not connected to anything. So that is these are coupled buses here. So they are undergroundly connected with these transformers. So here you can see these lines connected. So they are charged by these lines. After that, you can see here is the potential transformer. So I may have given some details of these transformers in previous videos. So here I am giving just an overview of this grid station. Here you can see the transformer. So for a transformer, I will make a separate video which will describe the intricacies of all the parts and all the things of the transformer. As of now, you have to see the main outline of this grid. So I have given it. Here is the additional which is connected to that transformer. Then after that, this is a 33 kV side here with no hissing sounds, thanks to God, because I think sound is produced by high voltages, and high voltages were on that 220 kV side. So here is the main light tower. Here it is used for lighting purposes in case of night maintenances. This is the 33 kV control room. Here this is all from Siemens and other companies. So here they are all marked from where to where these lines are going. Lassipora, Kigam, Sitco, Lassipora, where the grid is situated itself. Pulwama. This is Bulltech something, LV1. So you have all these markings, so it shows from where it is coming and where it is going. So all those diagrams and all those protection systems above, you can see. So a lot of engineering has to be done in order that our lighting and our systems remain working 24/7. So the one of the main of this grid is that all the systems which are very delicate and which are very necessary for the grid are put inside these buildings. So I can hear only the sounds of only myself and not any other sound. So this is a somewhat cool atmosphere inside this building. So that, and especially for the systems which are present here, systems remain unaffected from atmospheric conditions, so they may get a prolonged working life. So that is beneficial in the long run. So as of now, this system here, you can see where we were and where we have come. And this side, low voltage, neutral CT. So these are systems are meant to protect and provide a more independence of technology and all that. So these systems help us in a lot of features and lot of things, because these systems, because the main feature of this protection, this is almost I have seen from many grids that 40 to 50% or maybe 60% of the system that is used is the protection system that are connected. Those systems are which are used for protection mechanisms. So only for this, the main part is the transformer. So it is many protection mechanisms there. And after that, circuit breaker, so it is a whole building of circuit breakers there, as you have seen. So there are many protection systems. So this is a necessary thing for to work upon, because in the end what matters is protection of people, and all that infrastructure is meant to protect people and transfer energy efficiently, because lives matter more than energy transfer. That is why there is a lot of deal that has been done for protection. So with protection here, in the electrical side of the life and the world, with protection there also comes efficiency. So where protection is better, efficiency will also be better. It's not for every case that would be proportional, but still here in the grids that is proportional. So let me show you the we were walking. This is the main basic structure of the grid. You can see how much work has been done on this yard itself. First they have created those underground paths so that the lines may be put underground. Then after that, these small pebbles, they help to, in case of any dissipation, just like here there is some water or some oil maybe have been put here, so it gets seeped directly into the ground. And in case of these transformers as well, if there is an oil seepage or something, so these transformers may lead to fire. So that's why there is a need of the oil to get inside the ground quickly. So here, this is the open system of this OTI. This is an auxiliary transformer here, so it has not been charged as of now. They may be working on something. OTI, oil temperature indicator. You can see all those relays connected with it. These are the fan controls here. You can turn on and off all those fans. This is the WTI, winding temperature controller. You can see those systems. So as of now, let me finish this video here. And so in a nutshell, I may say that this is one of its own GIS grid, one and the only GIS grid in this whole valley. So you can see how intricately it has been built. So here was these lines, those lines that are coming from this 33 km, they are going towards Kigam, Sidco and Lassipora side, R, Y and B. So is the AIS grid. These AIS grids, as I may have given you the videos of these AIS grids, so these grids are working since electricity was commissioned here. From then, now those grids are shifting to GIS type grids like this one, and GIS grids are much better alternative for energy transmission, efficient and noteworthy. Systems work in line to line. Close the door. So this was about the GIS grids. I see you in the next video. Till then, take care. Allah Hafiz.